All right, you guys, let's go ahead and continue our lesson on variation. In this first example that we have, we're going to do an example of direct variation. So first, let's read our prompt. So it says, directions. The monthly payment P on a mortgage varies directly with the amount borrowed B. If the monthly payment on a 30-year mortgage is $6.65 for every $1,000 borrowed, find a formula that relates the monthly payment P to the amount borrowed B for a mortgage with these terms. Then find the monthly payment P when the amount borrowed B is $120,000. Okay. So the first thing you want to do anytime you're given a direct or an inverse or a joint, just any type of variation problem, is you want to ask yourself this question. What type of variation is this? All right, you need to identify what type of variation that you have so that you can properly apply the right model. So as we look at our problem, okay, the important thing to know is that it's not going to be a guessing game. They're going to have to tell you what type of variation you have. So if you look right here, it says that we have direct variation. It tells us that our two variables vary directly with each other. So we can go ahead and answer that question. We have direct variation. So what that means is, in my mind, I need to think about, okay, well, what equation goes with direct variation? Well, we know that that is y equals k times x, okay? And that's read, y varies directly with x. That's how we read that particular model, okay? All right, so the second question we need to ask ourselves after we've identified the variation is, what are my variables? Okay, so if you're looking at your problem, your model always says you have y and x, but that may not always be the variables that you have in your particular problem. So as we look at ours, all right, we can see here that we have a variable monthly payment, which is P, and we also have the amount borrowed, which is B. Okay, so for us, we have two variables that are no longer y and x, but P and B. So let me go ahead and write that. So for us, P is the monthly payment, and B, they told us, is the amount borrowed. All right, so we know what type of variation we're dealing with. We know what our variables are. The second thing is that I need to properly place my variables into the model. So I need to put them in the right order. So our problem says, zoom out a little bit for us. Our problem says that the monthly payment P on a mortgage varies directly with the amount borrowed B. So if we are placing our variables exactly as they are into the model, what we are going to have is P varies directly with B. Okay, so our new equation is P equals K times B. All right. After we've identified our variation, our variables, and we've put them in the right order, the next thing we're going to want to do is we need to solve for K. Okay, so remember, K is your constant of proportionality. So we know how our variables are moving in respect to one another, but we need to know by how much. Our K is going to tell us that. So in order to find K, all right, there is going to be a relationship that already exists between your variables in your problem. All right, so let's see if we can find that relationship. So in the second sentence of our problem, it says if the monthly payment on a 30-year mortgage is $6.65 for every $1,000 borrowed. All right, so there's our relationship right there. If our monthly payment is $6.65, then we borrowed $1,000. Okay, so they gave us a P, which is a monthly payment, and they gave us a B, which is the amount borrowed. So the relationship is this is our P, and 1,000 is our B. Okay, so let me go ahead and write that down. So P is $6.65, and B is $1,000. Now, with that relationship, I can go ahead and plug those values in to our model that we already set up, and then we can go ahead and solve for K. So let's go ahead and do that. So we can say $6.65, because that's my P, equals K times 1,000. All right. So since we're solving for K, that means we need K isolated on one side of the equation. Isolated, remember, means by itself. So I'm going to divide each side of my equation by 1,000. When I do that, K is equal to 0.00665. That's my K. All right. So now that specifies my model that I have. So instead of just knowing that I have P equals K times B, I know exactly how much those variables are differing with each other as I manipulate one. So now I can actually write my model as P equals 0.00665 B. That's my new model. Okay. Now that I have that set up, let's go back to the prompt of the problem to see what exactly they wanted me to find in the first place. So it says, once you find a formula that relates the monthly payment P to the amount borrowed B for a mortgage with these terms, okay, then find the monthly payment P when the amount borrowed B is $120,000. All right, so they want us to find the monthly payment P when the amount borrowed B is $120,000. So we are looking for a P when B is that much. All right, so let's go ahead and write that down. All right, so the question we are asked is to find P when B equals $120,000. All right, so since we have our equation, we can go ahead and plug this information into our model. So we're looking for P. So P is going to stay as a variable because we don't know what it equals. And we're going to say 0.00665 times 120,000. All right, and when we multiply that together, it's going to give us our P, which happens to be $798. So that means if you borrow, all right, $120,000 from this particular institution, your monthly payment on your mortgage is $798. All right, cool. So let's check the solution to see if we're correct. All right, so just like we did, we set up our equation. We then solved for our constant of proportionality, so we're good here. All right, and then once we did that, we answered the second part of the problem where we plugged in $120,000 inside of our model and got 798. Awesome. All right, so if we were to graph that, okay, remember direct variation means that your variables are moving in the same direction. So as our amount borrowed increased, so did our monthly payment. So you can see that this is a linear equation that has a positive slope. All right. That concludes that example.